Welcome back. Let's move on to the third part of today's course, on-site teaching of PIT testing. And we will show you all the operating process of PIT testing. After this part, we will introduce the RSM PRTR, Pi Integrity Tester, and our super promotion activity. Don't miss it. Okay, the class begins.
RSM PRTR Low Strain Pile Integrity Tester Operation Teaching Video. 1. Device Description. The necessary parts for testing includes instrument host, acceleration sensor and connecting cable, excitation equipment, couplant, power charger, auxiliary tools, etc. Collect information and materials of the detected project before testing. Prepare all the tools and record charts needed for testing. They mainly include testing instrument, acceleration transducer, tape measure, coupling agent, excitation equipment, measurement certificates for instruments and transducers, the on-site record chart for the low-strain reflected wave method. Butter is preferably used as the coupling agent. Vaseline and gum can be used instead in case of emergency. 2. Applications. Low strain is suitable for detecting the integrity of the concrete pile body and determining the extent and locations of the defects of the pile body. Applications. Standard test method for low strain impact integrity, testing of deep foundations, technical code for detection of building foundation pile, dynamic testing technology regulations on highway engineering foundation pile, non-destructive detection code for railway engineering foundation pile, technical code for detection of building foundation, technical specification for testing of existing building foundation, technical specification for foundation piles testing of highway engineering, technical code for testing of foundation soil and building foundation. The stress wave is generated by applying an excitation signal on the pile top, of which the response signal is received by the sensor mounted on the pile top. During the propagation of the stress wave throughout the pile body, in case of any discontinuous profiles with defects such as pits, mud, fractures, holes, etc., and the bottom, where the wave impedance changes, the reflected wave will be generated. The information such as the pile length and the position of the defects in the pile body can be obtained by testing and analyzing the propagation time, amplitude, phase, and curve characteristics of the reflected wave, so as to evaluate the integrity of the foundation pile at last. 3. Operation Preparation. 1. Before the detection starts, the pile head needs to be treated. The top surface of the pile should be flat, compact, and perpendicular to the pile axis. The mounting point of the transducer and the tapping point should be ground and smooth. 2. During site test, it is best to prepare several types of excitation equipment and select and use according to the actual purpose of detection. In terms of relatively long piles, when it is required to detect the reflected signal at the bottom of the pile, the excitation equipment with softer materials, a large mass, and a large diameter should be selected. In terms of relatively short piles, when it is required to detect the reflected signal of shallow defects on the pile body, the excitation equipment with harder materials, a small mass, and a small diameter should be selected. 3. Measure the pile diameter, millimeters, and record it in the on-site record sheet. 4. Before testing, connect low-strain sensor to the instrument. 5. The bottom of the acceleration transducer is installed at the top surface of the pile, 2/3 of the radius away from the pile core through butter bonding. Installation requirement. The tighter the installation is, the better. 6. The work of the inspection personnel is divided in advance, and each performs its own functions. Under normal circumstances, one person is responsible for instrument operation and on-site recording, and one person is responsible for the installation of the transducer and tapping. 4. Host introduction and settings. 1. Turn on the power. Please wait for initialization, about 30 seconds. On the main interface, there are 4 main function buttons: RSM mode sampling and PIT mode sampling, export data, delete data. The upper part of the screen displays the current time, the power of the host, and the measure can be switched. There are 3 buttons at the bottom: Set, Update, and About, which can be used to set the time, screen brightness, screensaver duration, and interface style. Viewing of instrument software upgrades and software-related information. RSM mode and PIT mode are only the difference in operating habits. Generally, it is recommended to select RSM mode when sampling. 2. Click the RSM sampling to enter the RSM sampling interface, which is composed of 3 sections including the curve display section, parameter section, and operation command section. The meaning of each parameter in the parameter indication area. P. It stands for the name of the folder where the current file is saved. F. It stands for the file name used when the current signal curve file is saved. L. It stands for the preset pile L value set by the user in the setting menu. C. It stands for the preset velocity value set by the user in the setting menu. E. It stands for the X magnify value set by the user in the More Settings menu. T. It stands for the sampling interval. 3. Click the Settings button to enter the Basic Information Setting interface. Project. Set the project name, which is mainly saved as information. Save path. It stands for the name of the folder where the sampled signal in the current file is stored, which shall not be Chinese characters. Pile number. The number of the test pile. The pile number will be automatically saved as the file name of the data saving. The plus and minus signs on the right side of the pile number can be used to increase or decrease the previous pile number by 1 respectively, and the pile number revised will be displayed in the box. Select the C grade and pile type based on the relevant site data and enter the relevant pile diameter. Click Pile L and Velocity. Set the pile length based on the relevant site data. Set the velocity based on the corresponding C grade. Or click the reference on the right to set the velocity value corresponding to the corresponding C grade. Interval can be selected as automatic or manual. It is recommended to use auto. Amount selection range: 3, 6, 9, 12, 15, only single choice. The H-pass and L-pass are set up to filter the collected signals. In this way, the acquisition curve is smooth and has no interference, and the defects and the reflected wave at the bottom of the pile can be clearly distinguished. Generally, the high-pass filtering is set as 0, and the low-pass filter is set as 2000 or 1000. Click the More Settings. You can set information such as X magnify, X local, delay point, point D, trig level, test point, sensor settings, remark, and so on. X magnify is set up to ensure that the signals at the bottom of the pile can be clearly displayed without clipping the signals at the pile head. The index should not be set with a too large value. Otherwise, as a result, the signal curve will be easily distorted and the defects in the deep part of the pile will be excessively highlighted. Point D. Set the distance between the excitation point and the installation point of the sensor. Trig level. Click and set the appropriate trigger level to reduce the impact of external vibration or noise on the sampled signal. Test point can choose single measuring point mode or multiple measuring point mode as required. Sensor settings according to the parameter settings on the sensor certificate. The recommended value of delay points is 50. Click OK in the interface of settings and return to the main interface of low-strain data acquisition. 5. Data sampling and on-site analysis. 1. After all the settings are completed, you click on SAMP C. After the prompt "Please hammer" appears at the window number 1, the pile head is hammered once, and the collected signal curve will be displayed at the window number 1. After several consecutive hammerings, acquisition is automatically stopped until the number of acquisition meets the setting requirements. The acquired signal curves are sequentially displayed in the respective windows of the curve display area. When the signal acquisition curve of a certain window is abnormal, you can select this window and click SAMP in the operation command area to reacquire the signal. The signal will cover the original acquired signal. 2. Click Save or New in the operation command section of the sampling interface, and the pile number will be automatically saved in the settings interface as the file name. When there is already a file with the same pile number in the save path, the system will pop up a prompt box. Click OK to save the file and overwrite the original pile file. Click Cancel to abandon this save, clear the screen, and prepare to collect signals again. Click PLD. You need to re-enter the new station and save the signal. 3. If you click on Browse in the operation command area, the signal curves of all files in the current path will be displayed in turn in the curve display area. At the same time, the F area in the parameter section will display the file name of the open file in real time. Scroll. When the number of currently sampled signals or open files exceeds 3, click the scroll button to turn the page, and the 3 data curves on the next page will be displayed in the curve display section in sequence and cycle. If you need to open or delete the collected data, you can click Open in the operation command area to enter the interface of Read file. If you need to analyze the collected data on the site, you can select the signal curve that requires analysis. Click the button of Analyze in the operation command area and enter the interface of analysis. The analysis interface is mainly divided into Curve Display Area, Pile Schematic Display Area, Operation Command Area, and Parameter Section. Click Fix L to switch between Fix L, Fix V in turn. When Fix L is displayed, it means that the current analysis is performed in the Fix L mode. That is, the velocity is calculated based on the fixed pile length. On the contrary, when Fix V is displayed, it means that the current analysis is performed in the Fix V mode. That is, the pile length is calculated based on the fixed velocity. Click on the top. Here we'll alternate between the top, the bottom, and the defect. When top is displayed, the instrument automatically identifies the maximum peak value of the signal curve in the curve display area as the pile head and adjusts the position of the pile head in the signal curve through left shift and right shift of the operation command area. At the same time, in the schematic area of pile below the signal curve, the position of the pile head will also be adjusted accordingly. When bottom is displayed, the instrument automatically identifies the position of the pile bottom according to the preset pile length and the preset wave velocity, and adjusts the position of the pile bottom in the signal curve through the left shift and right shift of the operation command area. At the same time, in the schematic area of the pile below the signal curve, the position of the pile bottom will also be adjusted accordingly. When defect is displayed, the position of the defect is determined between the pile head and the pile bottom through left shift and right shift. The depth of the defect to the pile head is automatically calculated in the schematic area of pile below the signal curve. Click the E+ or E- button to increase or decrease the X magnify by 1 on the curve currently analyzed. The curve can also be flipped, scaled, low pass, high pass filtering, etc. 5. If the analysis result needs to be saved, click the Save button to save the analysis result in the data file. Click the Exit button, return to the data acquisition interface. 6. After the on-site sampling and saver analysis, the data is exported through the U-disk configured by the instrument, shut down, and the test is ended. 6. Precautions. 1. The concrete strength of the inspected pile shall not be lower than 70% of the design strength, and shall not be lower than 15 megapascals, and the age shall meet the requirements of the specification. 2. The pile head needs to be handled in strict accordance with the specifications. It is recommended to prepare a variety of vibration excitation equipment and hammer pads to identify the reflected signal of defects in different parts. 3. The transducers, sensors, and other equipment used in the test should be handled with care during installation and transportation. When using equipment, should operate accordance with the requirements of the instructions.